Okay, 55 degrees. Now, period 4, you weren't with us, or we didn't do this lesson in class. So I want to make a big deal about two things. One, where this angle intercepts the arc, that's called the intercepted arc. It's like biting it off here and here. And if you follow the legs of the angle where it crosses this circle is going to give you the intercepted arc. Follow the legs, follow the legs. Where it bites it off at A, where it bites it off at B is going to give you the arc that goes along with the angle. Okay, use your highlighters when you do these lessons because sometimes it's hard to see which angle goes with which arc. All right, let's look at example 1. We want to find the measure of angle BPC. So BPC is this angle. Well, this angle is a central angle. So this central angle is going to match the arc BC. But we also see that we're given angle BAC, and BAC also intercepts this same arc BC. So what we just learned is that if this angle, which is smaller than this arc, is 20 degrees, then we know that the arc is twice as big. So the measure of arc BC is equal to 2 times the angle BAC, and that angle measure happens to be 20 degrees. So the measure of the arc is 2 times 20, which gives me 40 degrees. This is 40 degrees. Now, because this is a central angle, and we just learned that the central angle is equal to the measure of the arc, then the measure of angle BPC is also 40 degrees. Use your highlighters and don't be afraid to mark your pictures. Find the measure of BAC. BAC is this angle, but we also see that they're giving me the angle of BPC. Both the green and the pink bite off or intercept the same arc measure. If this is a central angle, 80 degrees, then the arc is also 80 degrees. And since the arc is bigger than the intercepted inscribed angle, then we can simply take the 80 degrees, divide it by 2, and we get the measure of angle BAC. BAC is simply 40 degrees. Here we're given the inscribed angle, and we multiplied it by 2 to get to the arc. And here we're given the arc, and we're dividing it by 2 to go back to the angle. These problems aren't any more difficult than that, except for you have to realize, are they giving me a central angle, where the angle and the arcs are the same, or are they giving me an inscribed angle where there's a 2-to-1 ratio? The arc is twice as big as the angle. Look at example 3. Find the value of x. Well, here's an x and here's an x, so there has to be a relationship between these two. And what we do see is that both the angle here to here bites off this arc, and the angle from here to here bites off the same arc. This is an inscribed angle, this is a central angle, so there's a relationship of 2-to-1. This angle is twice as big as this angle. So we're going to take the bigger angle, 3x plus 8, and set it equal to, not 2x, because these are not equal, but we have to multiply the smaller by 2 in order to get to equal the bigger. This side is bigger, this angle is smaller. 2 times the big is equal to 2 times the small. We did this when we did mid-segments. We multiply the small by 2 in order to get to the big. So we end up with 3x plus 8 is equal to 4x. Subtract 3x from both sides. We end up with 1x equals 8 degrees. If we substitute 8 into x, we have 2 times 8, and we see that this is merely 16 degrees, and we know that this one should be twice as big. Well, 2 times 16 should be 32, right? So let's plug this in. 3 times 8 plus 8. 3 times 8 is 24. 24 plus 8 is simply 32 degrees. This is twice as big as this. A special case, and I want you to put a star next to 6. A special case is when your chord is the diameter. We know that the diameter cuts the circle into 2 equal parts. So we know that this is a semicircle, which is 180 degrees. If this is the diameter and this is 180 degrees, we know that the rest of the circle must be 180 degrees. Look at this 42. Don't forget to highlight the legs of the angle. It's biting off this arc. Okay. This arc has everything to do with this angle. It has nothing to do with the semicircle. So we don't need this time, but I want you to be aware that sometimes this semicircle will help you to solve the problem. Instead, we're going to look at the angle. The angle is smaller than the arc, so we're going to do the big equals 2 times the small. And in this case, the big is my arc, the measure of arc, WV. Look at that. I say WV and I wrote M. I'm a loser. Okay, so we have arc WV is equal to 2 times the small, which is 2 times 42. 2 times 42 is simply 84 degrees. Now, the question doesn't ask me to find x to w, but knowing this is the diameter, this is 180, and this is 84 degrees, could we find this missing arc? Sure we can. If we take what we know, a circle has 360 degrees, minus the 1/2 because of the diameter, and minus the 84 degrees, we should get what's left over. And 360 minus 180 is 180. And 180 minus 84 is 6. 8 from 17 is 96 degrees. If we add these all up, we should get 360 degrees.